Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P. In a certain game of chance, a square board with area 1 is colored with sectors of either red or blue. A player who cannot see the board must specify a point on the board by giving an x-coordinate and y-coordinate. The player wins the game if the specified point is in a blue sector. The game can be arranged with any number of red sectors, and the red sectors are designated so that Ri is equal to 9/20 to the power j. Here is a problem for today for exam P on probability. In a certain game of chance, a square board with area 1 is colored with sectors of either red or blue. A player who cannot see the board must specify a point on the board by giving an x-coordinate and a y-coordinate. The player wins the game if the specified point is in the blue sector. The game can be arranged with any number of red sectors, and the red sectors are designed so that Ri equals 9/20 to the power I, where I is the area of the ith red sector. Calculate the minimum number of red sectors that makes the chance of player winning less than 20%. And here's the solution. Suppose there are n red sectors. Let W be the probability of a player winning the game. Then W is the probability of a player missing all red sectors. That's the probability we're looking for. And that's equal to, W is equal to 1 minus, because it's a 1 by 1 square that we're working with, it's just 1 minus the sum of the areas of all the red sectors. And that sum is equal to 9/20 to the power 1 for the first sector, plus 9/20 squared for the second sector, and so on up to 9/20 to the nth for the nth, the last sector. And that expression in parentheses is a partial sum of a geometric series, but it doesn't start with 1, so we factor out 9/20, and then it starts with 1, and it becomes 1 plus 9/20 to the first, plus and so on up to 9/20 to the n minus 1. And such an expression starting with 1, we know that that's equal to 1 minus the ratio of the series 9/20 to the nth over 1 minus the ratio of the series, which is 9/20. Okay, 1 minus 9/20, that's 11/20. 11/20 times 20 is just 11. So we really have there 1 minus 9/11 times the whole expression 1 minus 9/20 to the nth. We multiply it out and then recalculate, and we end up with 2/11 plus 9/11 times 9/20 to the nth. And we want W to be less than 0.2, so we want this expression that we just obtained, 2/11 plus 9/11 times 9/20 to the nth, to be less than 0.2. And equivalently, that's the same as 9/20 to the nth being less than 11/9 times 0.2 minus 11/9 times 2/11. And that's equal to 2.2/9 because 11 times 0.2 is 2.2. Minus 2/9 because 11 and 11 cancel out. So that's 0.2/9 or 2/90 or 1/45. And then we can take the natural logarithm of both sides and solve this inequality for n. So this is equivalent to n times the natural logarithm of 9/20 being less than natural logarithm 1/45. And then we need to calculate what this means in terms of n, but of course to do this we would need to divide both sides by the natural logarithm of 9 over 20, which is a negative number because 9 over 20 is a fraction. So then the direction of inequality changes, and this becomes n is greater than ln over 1 over 45 over ln of 9 over 20. Okay, well that's equal to minus ln of 45 over minus ln of 20 over 9. Of course the minuses cancel, so it's natural logarithm of 45 over natural logarithm of 20 over 9, and that's approximately 4.76722.079. Since n must be an integer, the minimum number of red sectors that makes the choice of a player winning less than 20% is 5, which is answer C. Please remember this is copyrighted material. The problem itself belongs to a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.